Hello and welcome. In this video we want to prove that limit of ln of x over x to the p when x approaches infinity equals 0, which in this formula p can be any positive number. P, for example, can be 2, 5, 3.5, 7.2, 10 billion and so on. Any positive number. And by proving that limit of ln of x over x to the p when x approaches infinity equals 0, basically we show that the logarithmic function, remember ln of x is a logarithmic function, and in general by proving this we will show that logarithmic function approach infinity is slower than any power of x. Actually it shows that the growth of logarithmic function is slower than polynomials. Okay, let's prove this limit. So we want to prove that limit of ln of x over x to the p when x approaches infinity is 0. And we are going to use L'Hopital's rule to prove this. Why we can use L'Hopital's rule? Because when x approaches infinity, ln of x goes to infinity, so numerator approaches infinity. Also infinity, x goes to infinity, infinity to p to the power of p is also approaches infinity. So we are allowed to use L'Hopital's rule for this limit. The limit is in the form of infinity over infinity. If we take the derivative of numerator is 1 over x and the derivative of denominator is p x to the power of p minus 1 as x approaches infinity. Let me show you here how we can simplify this 1 over x over p x to the power of p minus 1. For simplifying this expression, this fraction, you can do it in different ways. But here I am going to do it this way. I am going to multiply numerator and denominator by x. If you wonder why I am doing this, because I want to get rid of the fraction 1 over x in numerator. And so I am going to multiply it by x, because in denominator of 1 over x there is x. So to get rid of that x, I am going to multiply it by x. So I want to multiply numerator and denominator by x. And attention, x over x is 1, so it doesn't change the value of the expression. By doing so, 1 over x times x in numerator would be 1. And if you multiply x to the power of 1 by x to the power of p minus 1 here, if you add the powers, p minus 1 plus 1 would be p. So in denominator we get p x to the p. So after simplifying 1 over x over px to the p minus 1, we have this limit of 1 over p x to the power of p as x approaches infinity. And what is this limit? It is simply 0, because x approaches infinity, and limit of x to the p when x approaches infinity is infinity, and 1 over infinity is 0. And this completes the proof of this limit. I hope you liked this video, and see you in the next videos.